material strong enough for the tallest buildings and largest dams, yet versatile enough to take on virtually any shape or form. This material is ideal for the construction of our schools, our bridges, our factories, our homes, our sidewalks, and our roads and highways. It is used as a long-lasting, weather-resistant medium by artists and sculptors, and has been used to form a 96-mile-long barrier between freedom and communism. This material would never rot or rust, never need painting, and would resist fire. This material, concrete, is the most widely used building material on Earth, one with the natural properties of the stone from which it originates, plus its own unique qualities. The secret of this remarkable material is a single and essential ingredient, the glue that binds stone and sand together into concrete, a fine gray powder called Portland cement. Here in Dixon, our relationship with the manufacturer of Portland cement began in 1906, a century-long story that is steeped in history, a century-long story that sets its eyes on the future, and there's no better place to start our story than at the beginning. The year was 1906, and Theodore Roosevelt was in his 5th year as our nation's president. San Francisco was struck and shaken by a devastating earthquake, and the Chicago White Sox beat their crosstown rivals, the Chicago Cubs, in the World Series. And in March of 1906, construction began in Dixon on the Sandusky Portland Cement Company's newest cement manufacturing facility. The Dixon plant, built at a cost of $750,000, became operational in 1907 and was the 3rd such cement manufacturing facility owned and operated by Ohio-based Sandusky. In 1929, Sandusky changed its name to Medusa Portland Cement Company. Medusa continued to own and operate the plant here until 1980, when the plant was sold to Lone Star Industries. Lone Star operated the plant for 4 years, selling it in 1984 to Dixon Marquette Cement Company. In 2003, after 19 years of operation, Dixon Marquette sold the plant to Cemex, America's largest cement producer. Then in 2005, Cemex sold the plant and its 1,500 acres to the current owner, St. Mary's Cement Incorporated. Who is St. Mary's Cement? Headquartered in Toronto, St. Mary's is a leading manufacturer of cement and cement-related construction products, serving the Great Lakes region of the United States and Canada. Founded in 1912, St. Mary's has Portland cement manufacturing plants, cement terminals, ready-mix plants, aggregate operations, water transport operations, and trucking operations, located strategically to serve the Canadian and U.S. markets. Employing more than 1,500 world-class employees, St. Mary's is a true recognized leader in the cement manufacturing industry. St. Mary's Cement is part of Group Votorantim, a diversified and privately held Brazil-based company with market-leading operations in cement, pulp and paper, aluminum and metals, industrial films and chemicals, agricultural products, financial services, venture capital, energy, and international trade. Votorantim operates in 10 countries, employs more than 30,000 people, and is one of the largest cement producers in the world. Throughout the years, the Dixon cement plant has certainly undergone many expansions, modifications, and improvements. But the basic process of making cement here and elsewhere remains quite faithful to the original Portland cement recipe invented by Joseph Aspdin, an English stonemason, in 1824. Aspdin chose to name his invention Portland cement because the concrete made from it closely resembled a type of stone quarried on the Isle of Portland off the British coast. What is cement? Although the two words, cement and concrete, are often and mistakenly used interchangeably, cement is actually the fundamental ingredient in concrete. It's the fine gray powder that, in combination with water and a resulting chemical reaction, binds sand and gravel or crushed stone into the rock-like mass known as concrete. The cement manufacturing process can be summarized in 7 steps. Quarry activities and harvesting of limestone. Crushing of limestone. Proportioning, blending, and grinding of materials, preheating of materials, kiln heating and clinker production, clinker cooling and finish grinding, silo storage and shipping. Now, let's visit the Dixon plant and witness its cement manufacturing activities and workflow. The cement manufacturing process begins in our quarry as we gather the flour of the cement-making recipe, limestone. Limestone accounts for about 80% of the mineral content of cement, providing the necessary calcium component, and must be harvested in large quantities, requiring the quarry and the plant to be in close proximity to reduce transportation costs and transportation time. Without sufficient supplies of quality limestone, we can't make cement. That's why we are always looking to add to our limestone reserves so we can continue making cement here in Dixon for decades to come. Blasting is often called upon to break the limestone from the quarry face. The blastings are performed by highly trained, licensed, and contracted blasting professionals. Every blasting procedure begins with the drilling of a series of vertical holes up to 18 feet deep into the rock surface. The explosive loads are prepared, dropped into the drilled holes, and detonated by way of a timing method. Vibration monitoring is conducted using seismograph technology to ensure that each blasting is within guidelines and prescribed tolerances. After blasting, the plant's supersized quarry-grade loaders and hauling trucks gather and load the limestone slabs in preparation for the crusher units. After the limestone has been harvested, it is trucked to our primary crusher unit, where it is dumped into a hopper that feeds the primary crusher. Here, the limestone slabs are reduced to the size of baseballs and then fed onto a conveyor that takes the rock material to another crushing unit that further reduces the limestone into gravel-sized pieces. Then, the material takes a 20-minute conveyor ride to the plant. Crushed limestone enters the plant's storage facility and samples are collected for analysis in the plant's sophisticated laboratory. Laboratory technicians conduct numerous tests and evaluations on the raw materials and during several stages and phases of the cement manufacturing process to ensure strict adherence to cement-making standards. In the plant, the limestone material is blended in the proper proportion with the other necessary materials, sand, iron, and shale. Then, these materials are ground into a face powder consistency in a horizontal rotating tube that contains steel balls ranging in size from 1 inch in diameter to 3 inches in diameter, crushing and blending the raw materials. After grinding, the material is now ready for the preheater. Superheating the blended, homogenized material is necessary to the cement-making process. To save energy, the plant utilizes a 4-stage heating method that begins with the preheater tower. Here, utilizing a series of cyclone chambers through which the raw materials pass on their way to the kiln, the material is preheated before it enters the kiln. Rising more than 200 feet, hot exit gases from the kiln heat the raw materials as they swirl through the cyclones. The heated raw materials now enter the huge rotating furnace called a kiln. It's the heart of the cement-making process. A horizontally sloped steel cylinder lined with fire brick, turning from about 1 to 3 revolutions per minute. The kiln is the world's largest piece of moving industrial equipment. From the preheater, the raw material enters the kiln at the upper end. It slides and tumbles down the kiln through progressively hotter zones toward the flame. At the lower end of our kiln, fueled by petroleum coke, the flame reaches 3,000 degrees Fahrenheit. Here, in the hottest part of the kiln, the raw materials reach about 2,700 degrees and become partially molten. The intense heat triggers chemical and physical changes. Expressed in its simplest terms, a series of chemical reactions converts the calcium and silicon oxides into calcium silicates, cement's primary constituent. Monitoring the kiln process, as well as all other critical production processes, is the plant's control room. Here, computerized process controls monitor virtually every major production phase of the cement manufacturing process, from start to finish. At the end of the kiln, the raw materials emerge as a new substance, red-hot, marble-sized particles called clinker. The red-hot clinker tumbles onto a grate cooled by forced air. Once cooled, the clinker nodules are mixed with a small amount of gypsum. Then, the clinker-gypsum combination is ground in a finish mill, a horizontal steel tube filled with steel balls. As the tube rotates, the steel balls tumble and crush the clinker into a superfine powder. This gray powder, 150 billion grains per pound, is our final product, Portland cement. The Dixon plant can produce 650,000 tons of cement per year, enough cement and resulting concrete to pave a 625-mile-long 2-lane highway. The Portland cement is now ready for storage and shipping. The cement is pumped into one of our 26 storage silos, where it awaits bulk delivery into cement trucks that deliver the cement to ready-mix plants within 150 miles of Dixon. Once at the ready-mix plant, the cement will be mixed with water, sand, and aggregate materials to create concrete. Then it is delivered to the construction site. The cement industry is a significant component of the U.S. economy, with annual shipments valued at around $9 billion. In the United States, 39 companies operate 118 cement plants in 38 states, one of which is right here in Dixon. Not only does the cement industry contribute significantly to the national economy, but having the plant here in Dixon contributes significantly to the local economy. Consider this. The cement plant provides the area with 110 full-time jobs, with annual wages exceeding $6 million. Historically, an estimated $130 million have been paid out in wages since the plant opened in 1907. The plant also provides countless indirect jobs to the community as a result of the plant's existence and operation. Also, the plant pays over $300,000 in local and county taxes each year, with over $200,000 going directly to the Dixon public school system. And having the cement plant here helps to reduce the cost of concrete locally. As the Dixon cement plant enters into its second century of producing quality Portland cement, it is only fitting that we conclude this presentation by applauding and recognizing the dedication, effort, and commitment of the plant's past and present employees. And as we look forward to our new challenges, we thank in advance the world-class workforce that will take us to the next level.